When you gaze up at the night sky, what do you see? You might notice the familiar glow of the moon. Perhaps you can pick out the planets, steady points of light amongst a sea of twinkling stars. For millennia, humanity has looked to the heavens and found a sense of permanence and order. The stars appear fixed in their constellations year after year. The sun rises and sets with unwavering regularity, a celestial clockwork that governs our days and seasons. This perception of a stable, predictable universe has been fundamental to our understanding of the cosmos. It's a comforting thought, isn't it? The idea that the fundamental laws of nature are constant and reliable, providing a solid foundation upon which everything we know is built. The first hints that our universe might not be eternal came from the very heart of physics, from the realm of quantum mechanics. This is the science of the very small, the world of atoms and the particles within them. Down at these tiny scales, the universe behaves in ways that are strange and counterintuitive. Particles can be in multiple places at once. They can pop in and out of existence from nothing. It was by studying the fundamental particles that make up everything, including the famous Higgs boson, that physicists began to uncover a potential fragility in the state of our cosmos. Imagine the universe as a vast energy field stretching across all of space. Physics tells us that systems, whether a ball on a hill or the universe itself, always seek their lowest possible energy state. This is their most stable configuration, a state of rest from which they cannot be easily disturbed. A false vacuum is like that same ball, but instead of being in a bowl, it is resting in a small dip on the top of a very tall hill. According to the bizarre rules of quantum mechanics, this can happen. A random quantum fluctuation could, purely by chance, give a tiny region of our universe enough energy to tunnel through the barrier. This event would create a tiny microscopic bubble. But this is no ordinary bubble. It is a bubble of a new, more stable reality. The bubble will not remain microscopic. It will begin to expand outwards in all directions, and its expansion would be unlike anything else in the cosmos. The boundary of this expanding bubble of true vacuum would be a place of unimaginable energy. It would be a front of pure, cataclysmic energy, far more powerful than any supernova or gamma-ray burst. For anyone or anything in the path of this expanding wall, there would be no warning. Since the wall moves at the speed of light, no information about its approach could ever reach us ahead of time. Inside the bubble, the constants of nature that we hold so dear, the mass of an electron, the strength of gravity, the speed of light itself, could all have different values. The elements of the periodic table, the very building blocks of matter, would likely not be able to form. The universe inside the bubble would be a profoundly different place. To answer this, physicists have to become cosmic detectives, piecing together clues from the most fundamental particles in the universe. The discovery of the Higgs boson at the Large Hadron Collider in 2012 was a monumental achievement that allowed physicists to finally measure its mass with incredible precision. When they plugged this value into their equations, they got a truly startling result. The numbers placed our universe right on the edge of stability. We seem to be living in that in-between state, a metastable or false vacuum. The data suggests we are indeed in the shallow valley, not the deep one. Should you be looking over your shoulder for an expanding bubble of nothingness? The answer, unequivocally, is no. The timescales involved are so mind-bogglingly vast that they make the age of the universe seem like the blink of an eye. So, rest easy. The universe has been here for billions of years, and all the evidence suggests it will be here for countless billions more. The story of the false vacuum should not be a source of anxiety, but a source of wonder. It is a profound reminder of how much we are still learning about the universe. The fact that we can even contemplate such questions, that we can use mathematics and observation to probe the very stability of space-time, is a testament to the power of human curiosity. The universe is a vast and mysterious place, and we have only just begun to explore it. The greatest adventure of all is the one that lies ahead in the continued pursuit of understanding our magnificent home.